Okay, so let us start. This AICT sponsored Prerna Center for ST students at our VPK BIT Baramati. So here I am with the topic statistics and probability. So welcome all, and now let us discuss most of the things. So measures of central tendency means averages. There are 5 averages in statistics. So I am going to be very much brief because so many things are to be covered in this session. So the first is arithmetic mean. Here the simple logic is that we have to add all the observations and the addition is to be subtracted by number of observations. Geometric mean. Here we have to multiply all the observations and we are taking the nth root of the product of all the n observations. Geometric mean, and subsequently we can construct the formula in case of different forms of data. That form may be first hand, means primary data, or maybe secondary data, like that. Arithmetic mean, geometric mean, harmonic mean. In harmonic mean, whatever the number of observations we are with, we have to take reciprocals and then take arithmetic mean of the reciprocals. Finally, again take reciprocal of the, and that will be harmonic mean. Means harmonic mean is nothing but the reciprocal of arithmetic mean of the reciprocals of all the observations in the data. Then here the fourth is median. Median is the middlemost observation. And this is the only positional a measure of central tendency and more. So these are the 5 different measures of central tendency. In case of group data, I can say the formula will be summation xi observation is to be multiplied with fi frequency, sum over all the k classes, and that is to be divided by capital N. Capital N is equal to sum of all the frequencies of the classes I from 1 to k. Okay. Similarly, we can give the formula for geometric mean also. So what is to be done? We have to multiply of the all the observations. Suppose xi observation is appearing fi number of times. So xi into xi into xi fi times. So xi to the power fi. That is to be multiplied over all the k classes I from 1 to k. And we have to take nth root. Again, capital N is summation fi. Harmonic mean is the reciprocal of arithmetic mean of all the n observations. So the arithmetic mean of the reciprocals will be equal to, suppose xi is observation, its reciprocal will be 1 upon xi, and that is appearing fi number of times I from 1 to k, and that is to be divided by capital N and take reciprocal of that. So this is the formula for harmonic mean. Then median is positional average, and that depends, the formula is going to depend on which type of data we have. If we are just raw data, then we have to sort it first. And if number of observations is odd, then the middlemost. Suppose there are 5 observations, third will be the mean. If there are 10 observations, then we have to take middlemost 2, fifth and sixth, and take their arithmetic mean. That will be the median of the data. If we have grouped data means in the form of intervals, then different formula is going to be there. And mode. Now mode is the most repeated observation in the data, and we can find out it quickly. So this was just introduction of different measures of central tendency or averages. So let us see the first problem. There are so many problems we are supposed to discuss now. The spot seats observed at a road section are 66, 62, and so on. So the median is, so in the question paper it is mentioned answer with 1 decimal accuracy. So here we have to just sort, and simultaneously we'll be seeing how many observations are there. So, and chronological order. So whatever minimum, I think suppose 32. 32. The 32, I think 45, then 49. After that, 51, 53, 51, 53, 56. Then I think 60, 62, 66. 60, 62, and 66. So the, I think, how many observations are this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are 10 observations. And I have missed one observation, which is that 79. The last one is 79. Okay, these are n is equal to 10 hours. So this is an even number. This is an even number. So in this case, formula of median will be, actually in case of even, the formula is arithmetic mean of n by tooth and n by 2 plus 1 observations. So this is, we can understand these are first 4, these are last 4, and we have to take in between the middlemost 2 observations and their arithmetic. So it is obvious that will be equal to 54.5. So this is the arithmetic. This is the median of this data. So you can see that among these 10 observations, exactly 5 will be smaller than this, and again the same number of observations will be larger than this. So median is nothing but that value below and above which there are equal number of observations for the middlemost observations. Then measures of dispersion. Now see here, only studying some measure of central tendency does not realize us the entire data. So we have to see how much variation is there among the individual observations from their average value, and for that different measures of dispersion or measures of variations have been suggested. So very quickly I am going to discuss those also, because plenty of problems are there too which are to be solved, and every time if we are considering some particular data, the individual observations may have some unit, kilogram, centimeter, etc. And accordingly, the final numeric value of a particular formula will be having some appropriate unit. If it has some unit, then that measure is called as absolute measure. Absolute measure of dispersion. And if it does not have some unit, then it is called as relative measure of dispersion. So these are the two. And the first measure of dispersion is here range. Now range is maximum value minus minimum value. And suppose individual observations has have unit centimeter, then range will have unit centimeter. So this is an absolute measure. Then the second is coefficient of range. Coefficient of range, and the formula is maximum value minus minimum value divided by maximum value plus minimum value. So you can understand both the numerator and denominator will be having the same unit, which are going to cancel each other, and this will be a relative measure of dispersion. After that, there is mean deviation about mean. Okay. So the formula of this will be, I am going to write the formula in case of grouped data, and the formula will be, we have to first find arithmetic mean in X bar for the data, which is obtained by the formula summation fi xi upon summation fi. And after that, we have to consider every observation, then minus arithmetic mean of the data. So this is absolute value, means deviation of observation xi from its arithmetic mean. Since this xi is appearing a fi number of times, we have to multiply and we have to take addition over all the k groups. This is to be divided by capital N. This is mean deviation about mean. It will be having exactly the same unit as the individual observations have, and hence it will be an absolute measure of dispersion. Then the next is variance. Variance is, again, I am not going to explain in very much detail. Variance is denoted by sigma square, and the formula, what is to be done? Xi minus x bar whole square, and that is multiplied with fi. It is summed over all the k groups, and that is divided by capital N. So this is variance. If individual observations have unit kilogram, then variance will have unit kilogram square. So it again is absolute measure of dispersion, absolute. So this is equal to, if we simplify another formula, so it will be xi square into fi, summation I from 1 to k divided by n minus x bar to the power 2. So this will be the formula. Then next is standard deviation. Standard deviation, and that is nothing but positive square root of variance. That is sigma positive square root of variance, and that is again absolute measure. This is absolute measure of dispersion. Okay, and last is coefficient of variation. Coefficient of variation, CV. And this CV is equal to standard deviation divided by arithmetic mean, x bar, and that is multiplied with 100. So it is expressed in percentage. But it is quite possible that there might be some data for which arithmetic mean becomes negative. So we take absolute value, and you can see that whatever the unit individual observation is having, the same unit will be of sigma and arithmetic mean also. So that is going to cancel each other, and this is going to be a relative measure of dispersion. Okay, so these are different measures of dispersion. Whenever we want to check the consistency between two or among more than two different data sets, then we have to find coefficient of variation of every data. That data with the least value of coefficient of variation is going to be the most consistent, like that. So again, there is concept of moments here also. There are different types of moments. So I am going to explain moments. The first type is moments about an arbitrary value A. Arbitrary value A. So this is nothing but it is denoted by mu r dash A. So xi minus A to the power r is multiplied with fi summation I from 1 to k, and that is to be divided by capital N. The second is raw moment. Raw moments. And the notation is mu r dash, and that is equal to, just we have to put A equal to 0. So it will be xi to the power r is to be multiplied with fi summation I from 1 to k, and that is divided to be capital. So this is mu r dash. And central moments, central or moments about mean. So these are of concern to us. This is mu r, the raw moment, and the formula A is to be replaced by x bar. So xi minus x bar to the power r, that is to be multiplied with fi summation I from 1 to k divided by capital N. Yes, again there are relation between central moments and moments about some particular value A. So that is another part. Generally, we are finding moments until fourth order, and again there are some interesting facts. So mu1 dash is nothing but mean, arithmetic mean, mu1 dash. So then mu2 means second central moment, that is going to be variance of that data, like that. So we can understand that every even order central moment will be always non-negative. There are so many interesting things about this. So here let us go for skewness again quickly. Skewness is nothing but lack of symmetry. So we are departing or going away from symmetry of a data. If we have a data, we can plot it and we may get the structure, how the data has been spread over. So we may have different possibilities. It may be, if it is symmetric, then it will be looking like this, symmetric, perfectly symmetric about this line. In this case, skewness will be 0. We may have another situation as initially maximum observations are there and the frequency becomes smaller and smaller as we move further. And one more possibility is that initially comparatively less number of observations are there and maximum observations are at the higher end, like this. Now for the symmetric, this is perfectly symmetric ideal. In this case, arithmetic mean is same as median is same as mode. And that will be exactly equal to the highest corresponding value of x. Median means 50% observation smaller than this line and 58 the also corresponding value will be median. And mode means maximum height. So this is the maximum height and corresponding value of x will be the mode. Now, if we try to locate for the second data, this mode, this will be mode. Median will be somewhere here, median, and arithmetic mean will be here. So here arithmetic mean is greater than median and median is greater than mode. So this is positively skewed data. Positively skewed data. This is positive skewness. Exactly opposite thing is going to happen here. This will be mode. This will be median. And this will be arithmetic mean. So this will be negatively skewed. Negative skewness. Now, without drawing the figures, we can have some idea about the skewness of a particular data. For that, we have to find central moments, and after that, beta 2. Beta 1 is equal to mu 3 square upon mu 2 cube. This is the formula. And gamma 1 is called as coefficient of skewness, that is nothing but root of beta 1, and that is ultimately mu 3 upon mu 2 to the power 3 by 2. S where to find gamma 1. Now we can understand if mu 2 is variance, which is always going to be non-negative for any data, and the sign of gamma 1 will be solely depending on the sign of mu 3. If mu 3 is negative, gamma 1 will be negative. If mu 3 is positive, gamma 1 will be positive. If mu 3 is 0, then the data will be perfectly symmetric like that. Now, which of the following statements is not true? So let us just try to find out which of the following statement is not true. So whatever the problems I have taken here are solely from previous question papers. The measure of skewness is dependent upon the amount of the dispersion. Yes, the skew, I had written the formula. That's why I have explained in the previous slide about skewness. So that was the purpose, and in that I had written beta 1 equal to mu 3 square upon mu 2 cube. Now this mu 2 is nothing but variance, and that is measure of dispersion. So definitely skewness depends on the variation or dispersion. So statement A is correct. We want to identify which is not correct. In a symmetric distribution, values of mean, mode, median are same. Yes, that is also true. So already we have seen this is perfectly symmetric distribution. All the three things are going to be the same. So there is no problem with statement B. In positively skewed distribution, again, let me say positively skewed. So it is something maximum observations at the lower end. It's like this. So here mode. Median is somewhere here. And arithmetic mean is here. So mean third one in positively skewed. So this is positively arithmetic mean. Actually, Here arithmetic mean is the largest. That means it is positively skewed. So mean is greater than median and median is greater than mode. So there is no problem with statement C also. Now let us see the last one here. Negatively skewed means less observations at the beginning and maximum observations at the end. So in this case, so this will be mode. Then in between there will be median and arithmetic mean will be the list. So here mode is greater than no. So this is not correct, and so answer has to be option D. D is going to be the correct option. Okay. Now quickly I'm going to take review of this. I'm starting with probability theory. Of course, there are so many interesting problems. It is not possible to cover all the problems during this 2-hour session. Definitely, I will try to prepare some nice videos in relation to different parts. I'll be collecting question papers and then collect appropriate questions relating to a particular bit, and accordingly videos can be prepared. Experiment is an operation such that after completion of that only we are actually knowing the result. What is the result? What is outcome? That is possible result. Now deterministic means if an experiment has only one outcome, then it is called as deterministic, and if there are more than one outcomes possible for an experiment, then it is called as non-deterministic. Verifying some physical law such as V is equal to U plus AT or something. Then there may be Ohm's law or something. These are examples of deterministic type of experiments. Otherwise, if our experiment has more than one possible outcome, then that is called as non-deterministic. Sample space is the set of all possible outcomes of an experiment. Then different types of events are there. Event mathematically it is any subset of the sample space, and we can say that any phenomenon relating to an experiment and the study is an event. So we can define some particular experiment, and with regard to that experiment, we can define plenty of events. There is no restrictions as such. Now, what is let us consider here experiment rolling a die. So there are 6 spaces 1 to 6. These are the possible outcomes. Now let me tell you that once we have written the sample space, suppose sample space consists of only one outcome, then that will be deterministic. So nothing to learn in that case. But now see, you can see that sample space may have 2 outcomes, 3, 4, something like that. Some have infinite outcomes also, yes. And accordingly, we can define so many events on our own. So here A is defined. You can just take screenshot and everything. I'm not going to explain everything in detail. So even number, B is a number multiple of 5. So that is a singleton outcome. Such event is called as simple event. B is simple event. C at least 2 is in means to excluding 1, all are there. A negative number is seen, so there is no outcome favorable to event D. So it is called as a empty or an impossible event, because whenever the experiment will be performed, that is event is going to never occur, and hence its probability is 0, like that. And then E, event is either odd or even. Yes, you may get any outcome. Definitely event E is going to always happen. So E is as good as the sample space, and it is sure or certain event, its probability is 100%. Remember that probability of any event is at max 1. It can never be greater than 1. So whenever some people used to say that 101% or 2%, so these are meaningless statements. Event F, an odd number is seen, then event G, a number at most 3 is seen. As such, we can define so many events. And let me tell you that if there are a number of outcomes in a sample space, then we may write so many events which may contain 0 or 1 or 2 or all the elements in the sample space. As such, if you apply your logic of mathematics and previous formula, you will realize that the total number of events that we can define corresponding to a sample space with n number of outcomes is going to be 2 to the power n. This is very big statement I have made. I do not know whether you have followed or not. Now, mutually exclusive means two events are not happening simultaneously, then those are called as mutually exclusive. Means there is no common outcome. Means if one event is happening, definitely second is not happening and vice versa. So those are mutually exclusive or disjoint events. On the contrary, if their union adds to the sample space, those are called as exhaustive. So A intersection B is fine. So here A and B are mutually exclusive. Their union is not sample space, so those are not exhaustive also. C and F, as there must be something common in C and F, at least one element. So those cannot be mutually exclusive. Their union is not sample space, so those are not exhaustive. Events F and Z, neither mutually exclusive. Previous one C and F. C intersection F is sample space. So the C and F are exhaustive. Okay. Next combination F and Z, those are neither mutually exclusive nor exhaustive. And events A and F are mutually exclusive and exhaustive both. So this is really interesting. For a given sample space, you can define any event A. Definitely, as soon as we define an event A, automatically another event A complement is defined. And for any experiment, events A and A complement are mutually exclusive. Yes, because A intersection A complement is phi. And also exhaustive also because A union A complement equal to sample space. So this is a very obvious and important thing for any experiment. Events A and A complement are always mutually exclusive as well as exhaustive. Then equiprobable sample space. We say that if each outcome is equally likely to occur when the experiment will be performed, then we say that the sample space is an equiprobable sample space. There are very rare examples of experiments which have an equiprobable sample space. See, ideal examples are tossing a fair coin, fair, unbiased, honest, true. So many different words are used before the word coin or die. So that indirectly tells us that whatever the number of outcomes, each outcome is going to have the same chance of occurring when the experiment will be performed. So this is tossing a fair coin, rolling a die, then drawing a card from a well shuffled pack of 52 playing cards, something like that. So these are some examples of experiments which have an equiprobable sample space. Otherwise, there are plenty of other experiments which do not have an equiprobable sample space. But before that, for those experiments having an equiprobable sample space, the definition of the probability of occurrence of an event is given as the ratio of the number of outcomes favorable to that event divided by total number of outcomes. So this is called as the classical definition of probability. This is very standard example. What is the probability that a leap year selected at random will be containing 53 Sundays? We know that in general there are 365 days and a leap year contains one more day. So as such, there are 52 weeks plus 2 additional more days. Now, what is asked? What is the probability that a leap year selected at random will contain 53 Sundays? So Mondays. Okay. So in that leap year, number of Mondays may be either 52 or 53. If the first January is on Monday, then Monday and Tuesday will be appearing 53 times and remaining days will be appearing 52 times. As such, if First January is on Tuesday, then Tuesday and Wednesday 53 times, and remaining days on 52 occasions. As such, so these are the different combinations. And event a leap year selected at random will contain 53 Sundays. So being an equiprobable sample space, probability of A equal to N of A upon N of omega, and that is 2 by 7. Okay. The probability of A is 0, then A is equal to impossible event S and vice versa. Of course. Option B is A equal to 0. So A is a set or event. So it is going to be written in the form of set. It is so it cannot be a number. A equal to infinity is also meaningless. So only the option is A. Next problem. In a school of 1000 students, can the students play chess, 600 football? If 50 students play both chess and football, the number of students who play neither is, so it is the best way to draw the Venn diagram and you can get the answer quickly. So here 50 both. So C intersection F is equal to 50, otherwise, and thus the number of students who play at least one game is 250 plus 50 plus 550, that is equal to 850, and total number of students is 1000. So this is 1000 minus 850 is equal to 150, is very obvious. So these are I am repeating that these are the problems from previous NEET question papers. Two identical cube shaped dice. Dice is a plural form of a die. So there are two dice. Two dice are there. One to be are rolled together. The probability that an even number is rolled out on each die. Now see, again there is concept of independence. So we'll soon see that also. If again two events are independent, then probability of their intersection is equal to multiplication of the individual probabilities. That means if A and B are independent, then probability of A intersection be equal to probability of A into probability of B. Now here A event can be that an even number is seen on die 1 and event B an even number is seen on die 2. Then the probability that an even number is seen on each die, so probability of A intersection B, so being independent, probability of A into probability of B, probability of A is 1 by 6, probability of B is 1 by 6, and that is equal to 1 upon 36. A is the correct option. Then probability up to 1 decimal place. So in that some questions are you know that MCQs problems are there. One type is MCQ problem. There are 4 options. Exactly one is correct. Another type is MSQ, multiple selection questions. So in that 2 or 3 or all the 4 options may be correct. And the third category is no options are given to us, and in such case there is no any negative marking, and it is specified the accuracy of the decimal places also. Probability of consecutively picking 3 red balls without replacement from a box containing 5 red and 1 white ball. So these are really interesting problems. So there is a box which contains 5 red plus 1 white. These are the 6 balls. And without replacement, with replacement, these are the 2 categories. Here without replacement. So initially there are 6, and we have to find the probability that 3 red balls, all the 3 red. So 5 red balls are there. So in the probability that the first ball drawn is red is 5 by 6. After that, 1 ball is taken away. We are remaining with 5 balls, 4 red and 1 white. And being the second ball being red is equal to 4 into 5. And after that, after 2 balls have been drawn, we are left with only 4 balls. Out of 4, 3 are red and 1 is white, and probability that the third ball is red ball is equal to 3 by 4, and as such this is equal to, answer is 1 by 2. Okay. Next, a fair or unbiased or honest or true coin is tossed 4 times in succession and the results in the following outcomes: head, head, tail. The probability of obtaining tail when the coin is tossed on the fifth occasion. So I know that all the trials are independent of each other, so it really doesn't matter what the previous outcomes have been. So every time probability of head and tail will be the same, and hence the probability of getting tail at the next moment is going to be 1 by 2. The reason is independence. A 3-member committee to be formed from a group of 9 people. So here 9 people, how many committees can be formed? So there are 9, and from this, how many are to be selected? Three people are to be selected like this. So order is absolutely not important. That is a problem of combinations. So 9C3, this is the total number of committees possible. So 9 factorial upon 3 factorial into 6 factorial. So 6 factorial cancels. Then 7 into 8 into 9. Then 3 into 2. So this is, so as such, 12 into 7. So whatever may be 12 into 7. 84. 84 is the answer. Okay. Then actions of probability. Axiom is a statement which is accepted without asking its proof. When I say that a particular statement is an axiom, then nobody is supposed to ask its proof or justification. And as such, in probability theory, there are 3 axioms. Axiom 1 is probability of any event is greater than or equal to 0. So I am speaking that an event. There can be probability of an outcome also, and probability of an outcome is always strictly greater than 0. That is the slight difference. And in case of event may contain one outcome, two outcome, all the outcomes, or even none of the outcomes from the sample space. And as such, if that event does not contain any outcomes, means it is empty or impossible, its probability will be 0, and that's why axiom 1 is probability of any event is non-negative. Axiom 2, probability of sample space is 1. So probability of any event is never greater than 1. So 100, 1%, 200%, these are meaningless things. And axiom 3, for any two mutually exclusive or disjoint events A and B, probability of A union B equal to probability of A plus probability of B. It is very much obvious. A and B are mutually exclusive means those two events cannot occur simultaneously. A simple, this is sample space. Suppose this is event A and this is event B. So if event A occurs, B does not occur, and vice versa. So A, probability of A and B equal to probability of B, A plus probability of B, obvious. Otherwise means yes, I'm going to come to that also very soon. So these are the 3 theorems. I'm not going to prove these theorems. Each theorem has proof, but see, probability of A complement equal to 1 minus probability of A. Probability of impossible event is 0. Then probability of any event lies between 0 and 1. So whatever events we are talking, these are in general. So it is not necessary that the sample space of the corresponding experiment is equiprobable or not. Then if A is subset of B, this is read in set theory. But in probability theory, we have to read this as whenever event A occurs, event B also occurs. So in that case, probability of A is less than equal to probability of B. And the last is the addition theorem on probability for 2 events. So proof is larger and very easy also. Probability of A in any B equal to probability of A plus probability of B minus probability of A intersection B. So this is the most general statement. So whatever axiom number 3 was, it was like this: if A and B are mutually exclusive, that means A intersection B is phi and probability of phi is 0. That's why actually this statement is valid in that situation also, in any situation. So A and B are mutually exclusive, maybe mutually exclusive, may not be, maybe independent, may not be independent, maybe exhaustive, may not be exhaustive, like that. So this statement is going to be always valid. So these are the proofs, and then now a box contains 10 proofs, 3 of which are defective. So here we have a box. This box contains, so this is a box containing 10 screws, 7 non-defective plus 3 defectives. 2 screws are drawn at random with replacement. Again, with replacement, without replacement, this is really going to matter a lot. The probability that none of the screw is defective. So now in this case, with replacement. So now see, both the screws, none of the screws should be defective, means both must be non-defective. So probability that the first screw drawn is non-defective will be 7 by 10 into probability that the second screw drawn is non-defective, that is equal to 0.7 into 0.7, that is 0.49. That is actually exact standard way is 0.49, but in percentage we know that way to multiply by 100. So with replacement and with the replacement, these things have to be understood in a better way. If the same problem we are given without replacement, then what is going to happen? So that will be another problem. Now, what is the without replacement? In that case, the answer has to be, again, total number of outcomes. There are 10 screws, out of which 2 are to be drawn. This is the total number of ways, and in the numerator, favorable number of ways. So the 2 screws should be non-defective. So from the 7, we have to choose any 2, and means multiplication or means addition. From the remaining defective, none should be selected. So 7C2. So 7 factorial upon 2 factorial into 5 factorial, 3C0 will be 1. Then 10 factorial upon 2 factorial into 8 factorial, 2 factorial cancels as such. So we can see 8 factorial upon 10 factorial means 9 into 10 in denominator, 7 factorial upon 5 factorial means 6 into 7 in numerator, like this. So this is 2, this is 3. Again, 5, 7 upon 15. So I do not know what the actual value is. Now you can guess. You can use calculator. So I'm trying to use calculator, and 7 by 15, 7 divided by 15, that is coming as 0.466666 as like that. So you can see this much. Okay. So these are the slide. Different situations. Then we have to understand the concept of conditional probability and independence of event quickly. Yes, we have to be very, very quick. Otherwise, very less part is going to be covered. Conditional probability means some additional information is provided to us, and in regard to that, we have to find probability of certain event. So for that, to understand this example in a better way, quickly we are going to have this example drawing a card randomly from a pack of 52 playing cards. So these are the 52 cards in each. There are 4 suits, each containing 13 cards. So I think diamond, last is club, and the heart, spade, diamond, club. These are the 4. Ace, 2, 3, and 10, and then jack, queen, king. So these are 52. Now Being an equiprobable sample space, the total number of outcomes is 52, and that is not 52, it is 52C1, that's why 52. And I am defining three events. A king is a card drawn is a king card. Event B has a card time is a diamond card. Event C has a face card, like that. And we can logically see and condition, then mathematically also see, find out the probabilities, and then see whether this, if you pick any two events among these three, then pairwise these two events are independent or not. That can be thought logically as well as mathematically. So probability of A is 4 by 52, probability of B is 13 by 52, probability of C is 12 by 52. As such, A intersection B means A and B both. Actually, in this case, a king card and diamond card. So a king diamond. So 1 upon 52, probability of A intersection C. A intersection C is nothing but A, event A. So exactly 4 by 52. B intersection C, diamond and face. So 3 upon 52. Then probability of A given B means, see, we are trying to understand the concept of conditional property here. Event B is already happening. So a card is diamond. So in denominator there is 13. And what is probability that among these 13 diamond cards, one card drawn is a king. So it is 1 by 13, like that. Then probability of A given C, a card drawn is a face card, that is out of 12, 4 kings, so 4 by 12 is the probability. Probability of B given C, I have drawn a card, it is a face card, so 12 in denominator. And what is probability that it is a diamond? So out of 12, there are 3 diamonds, 1 by 4. Probability of B given A, already event A has occurred, I have drawn a card, it is a king card. What is the probability that it's a diamond? 1 by 4. Probability of C given A, I have drawn a card, it is a king card. What is probability that it is a face card? Yes, every king card is a face card, so 4 by 4, 1. So this is a sure or certain event, 41. And finally, property of C given B, already B event has happened. So 13 in denominator. So what is probability that diamond card is a face card? So 3 by 13. So initially 6 unconditional probabilities and later 6 conditional probabilities. So these are the 12 different probabilities we are seeing. And logically, when we try to see whether events A and B are independent, so logically, let us think in this way. If see, you are able to, you have drawn a king card. From that, you cannot tell whether it is diamond or not. And if a diamond card is drawn, from that we cannot claim that it is a king card or is not a king card. So there is no absolutely connection between events A and B. Events A and B are logically independent. Yes, events A and B are logically independent. That's why probability of A intersection B is exactly same as probability of A. Probability of B given A is exactly same as probability of B. And probability of A intersection B is equal to probability of A into probability of B. Now are the events A and C independent? Suppose I draw a king card. Can I tell that it is a face card? No. Now let us think another way around. I have drawn a card and it is a face card. Can I know that it is a king card? Yes. I have a face card. Definitely it is a king card. So definitely there is some connection between events A and C. So this cannot be independent. That's why probability of A given C is not equal to probability of A. That's why probability of C given A is not equal to probability of C. And that's why probability of A intersection C is not equal to probability of A into probability of C. And the third occasion is, are the events B and C independent? So let us think. I have drawn a card, it is a diamond card. From that, can I tell that it is a face card? No. Another way, if I have drawn a face card, can I tell that it is a diamond card? No. Answer is no on both the occasions, and hence there does not seem any association between events B and C. Hence, event B and C are going to be independent. And that is the reason why we are getting probability of B given C as exactly equal to probability of B. Also, probability of C given B exactly equal to probability of C, and probability of B intersection C is equal to probability of B into probability of C. So really nice. So a conditional probability is nothing but a probability evaluated with respect to a reduced sample space. Some additional information has been provided to us, and in regard to that, we have to find probability of some event. And the definition is probability of A given B is equal to probability of A intersection B upon probability of B. So this is mathematical definition of conditional probability. So all the previous probabilities, conditional probabilities can be recalculated by making use of this formula. Actually, we have found those by logic. In the denominator, probability of B, and that's why we mentioned that probability of B greater than 0. Already we know that it is style to write that provided denominator is not 0. So we could also write probability of B not equal to 0, but denominator is probability, and we know that already probability of any event is greater than equal to 0. Just we have to say that it is not 0. So strictly greater than 0. Now we have realized probability of A given B and probability of B given A. These are totally not associated with each other in any way. And the next question is probability of A given B and probability of A. What can be the relation? So greater than, equal to, not equal to, greater than equal to, less than equal to. So what is the appropriate relation? So here, if we see logically, if A and B are independent, then probability of A given B will be exactly is equal to probability of A. Exactly. Otherwise, if not independent, then will be provided that event B has already occurred, and because of that additional information, our sample space gets reduced and denominator is becoming smaller, so the ratio will be larger than the corresponding unconditional. So probability of A given B will be greater than equal to probability of A. You can see here, in case of A and C, probability of A given C, it is 1 by 3, and probability of A is 1 by 13. So probability of A is greater than equal to, actually greater than probability of A given C. Similarly, probability of C will be greater than probability of C given A. No. So, no. Probability of C given A will be greater than probability of C. Yes. Yes. Otherwise, here A and B are independent. That's why probability of A given B is same as probability of A. Probability of B given A is equal to probability of B, something like that. And then third one, probability of A equal to probability of A given what? So this is again really interesting, but I can answer quickly. So it is probability of A given the sample space. So this will be probability of A intersection sample space upon probability of sample space, and that is equal to probability of A upon 1, and that is equal to probability of A. So this is again very much interesting. Independence of events. Yes. So we have seen two events A and B are independent if A probability of A given B equal to probability of A, or probability of B given A equal to probability of B. That means if you simplify, then we are going to get probability of A intersection B equal to probability of A into probability of B. Then if two events A and B are independent, then events A and B complement are also independent. Event A complement and B are also independent. Events A complement and B complement are also independent. Okay, let us go for the next problem. Next problem. A and B are two random independent events. It is known that probability of A this much, this much. So which of the following is the value of probability of A? So we have to solve this such problems as quickly as possible. Probability of uh, A union B complement is equal to probability of A plus probability of B complement minus probability of A intersection B complement is equal to, now this is zero point 0.7, probability of A is 0.4 plus probability of, let us call this a small p, huh? Minus, now it is given A and B are independent events, so A and B complement are also independent, that's why this will be probability of A into probability of B complement. So this is will be equal to 0.3 is equal to P minus probability of A is 0.4, 0.4 into P. Just therefore 0.3 is equal to, this will be 0.6 P. Therefore P will be is equal to 1 by 2. Okay, or 0.5. Then P means probability of B complement. Probability of B complement is equal to 1 by 2. What is us? Probability of A union B. Probability of A union B equal to probability of A plus probability of B minus probability of A intersection B. So this is equal to probability of A is 0.4 plus probability of B. Actually, probability of B complement is half, means probability of B is also half. Minus probability of A intersection B will be probability of A into probability of B. Probability of A is 0.4. Probability of B is 0.5. So as such, 0.4 plus 0.5, that is 0.9 minus 0.2. And the answer is 0.7. 0.7. A is the correct option. As such, there are 25 calculators in a box. 2 of them are defective. Suppose 5 calculators are randomly picked up for inspection. Each has the same chance of being selected. What is the probability that one of the defective, that only one defective calculator will be included in the inspection? Think about this, how to solve this. So the with replacement or without, as such, we have to think, and accordingly you can solve. Already I have solved problems on with replacement and without replacement also. So I think options are somewhat just concentrate on this. Okay, something wrong is happening. Just go for the next problem. Two coins are tossed simultaneously. The probability of head simultaneously appearing. Again, this is problem on independence of event. Probability that first coin shows head is 1 by 2, and probability that second coin shows is also 1 by 2. So the correct answer is C, 1 by 4. 1 by 4 is the correct answer. So next. A fair coin was tossed 4 times in succession, and the results are head. I think that has been already discussed. Then binomial distribution. This is another very special and discrete type of distribution. There are so many standard distributions in the probability theory. Binomial, hypergeometric, Poisson, then negative binomial, geometric. So many distributions are there. In case of discrete and as such, the list is quite larger in case of continuous type of probability distributions. If a random variable is taking either finite or countable infinite number of values, then it is said to be a discrete random variable. If it is taking uncountably infinite values, then it is said to be a continuous type of random variable. Now, before string what a binomial distribution is, so we have to understand a Bernoulli trial. Bernoulli trial is an experiment in which exactly two outcomes are possible. Tossing a coin, gender of a baby, result. So many are examples, and out of the two outcomes, we are going to pure one that is called as a success, and the another outcome which we will not like to have is called as a failure. Now, for depending on that experiment, we can know the value of the probability of success and failure. And if we define x as number of successes in that only one trial, so x is equal to 1, that is nothing but success. Its probability is p. P is strictly between 0 and 1. P cannot be 0, P cannot be 1, otherwise it will be a deterministic experiment with exactly one outcome. So probability of success is P and probability of failure is 1 minus P, that is Q. Both are strictly between 0 and 1. P plus Q is equal to 1. So this is all about only a Bernoulli trial. But if the same Bernoulli trial is repeated n number of times with the condition that there are two important assumptions. The first assumption is that the probability of success and also ultimately the probability of failure during every trial is going to be the same. And the second condition is that independence. The results of all the outcomes are independent of each other. And hence, if a Bernoulli trial is repeated n number of times, then we are getting binomial distribution. So if there is only one match between India and some other country, that is going to be a Bernoulli trial, and we assume the same probability of India's win throughout all the series of 5 matches, then we are going to get a binomial distribution, and X will be number of matches that will be won by India out of the 5 matches. So that is a binomial distribution. So as such, if a Bernoulli trial is repeated n times, then the formula is NCX p to the power x q to the power n minus x from 0, 1 to until n. There are n plus 1 different possible values. And there are really some interesting facts. So definitely you must know, I'm giving just glimpses. For any discrete type of probability distribution, the way this is called as probability mass function, and it satisfies always two properties. You can consider some small x particular value, any real number, and probability that that random variable capital X takes that particular value small x is always greater than equal to 0. And the second condition is probability that the random variable takes particular value small x or all possible values of x is exactly equal to 1. So this is really wonderful. Yes, and you can check this also. This is going to be satisfied. Here also summation NCX p to the power x q to the power n minus x from 0 to n, and that is nothing but this is binomial expansion, actually p plus q to the power n, and that is 1 to the power n is equal to 1. So as such, problem, two coins are tossed simultaneously, probability of two heads simultaneously appearing is, so here quickly, x number of heads in two tosses of the coin. So X follows binomial with n equal to 2 and P is equal to, actually they should space true or honest or unfair, something like that. Otherwise it has no meaning. So the probability mass function is 2cx up to the power x into up to the power 2 minus x. And whenever P and Q both are same, then we have to modify this formula. The probability of two heads, so probability that x is equal to 2 is equal to 2c2, then up to the power 2. That is 1 by 4. 1 by 4 is the probability. Then a lot has 10% defective atoms. 10 atoms are chosen randomly from this lot. The probability that exactly 2 of the atoms are defective is, so here x is the number of defective atoms out of 10, x follows binomial with n equal to 10, and p probability that a particular atom is defective. So 10% defective, so 10 by 100.1. Yes. Then the probability mass function is given to us, and the probability that exactly 2 are defective is 10c2, 0.1 to the power 2, 0.9 to the power 8, and as such, this is the answer. Okay. As such, then consider the, yes. So what I want to tell that I did not discuss here or in this binomial. Yes, I can discuss what is mean, what is variance quickly. We may have any discrete type of probability distribution. Its form is, this is the form, and mean, its mean of the distribution is represented by expected value of x, and the formula is x into probability that random variable. This is the formula. So in this case it will be summation x from 0 to n, x into ncx p to the power x into q to the power n minus x. I am not going to solve this, but the answer is n into p. So mean is n into p, and then variance of x. Variance of x is, the original formula is expected value of x minus expected value of x whole to the power 2, and after simplification this comes expected value of x square minus square of the expected value, and in case of binomial the variance is npq. So we can understand, if mean is multiplied with q, then we are getting variance. In case of binomial, q is strictly between 0 and 1. So for binomial distribution, variance is always smaller than the mean. Further, the positive square root of variance will be standard deviation. So standard deviation of x will be square root of npq, like that. Okay. So here, consider the following. So it is given in this, variance of x is asked. So here, probability that p, x is probability that x is equal to 1 is p. Probability that x is equal to 0 is q. Then variance of x. Variance of x. Consider and this is Bernoulli. Means actually variance of x is n into p into q, but n is equal to 1 because this is Bernoulli. P is equal to 0.6, q is equal to 0.4. So this is 0.24 is the answer. 0.2. Then Poisson, I must specify here what is meant by a Poisson. This is problem on Poisson. Binomial was different, Poisson is something different. Again, Poisson is another special discrete type of probability distribution. And already we have seen Binomial. Poisson means number of accidents on a highway during a certain property period, number of defects found on a article, a number of misprints on a particular page. So the values of this Poisson random variable are starting from 0. So the values are x is equal to 0, 1, 2, 3 like that. And probability that the random variable x takes particular value small x is equal to e to the power minus lambda, lambda to the power x upon x factorial. This is the formula, lambda or m, whatever, and the values are this. So in case of binomial, the values were 0, 1 to 1 till n, means n plus 1 values, finite values are there. But in case of Poisson, there are infinite number of values. Even though infinite, this is still discrete because you can understand these are not continuous values. So these are countable values, countable. And yes, it satisfies the two properties for that x, for any x this will be greater than equal to 0, and the summation of all these properties for all possible values. So this will be e to the power minus lambda, lambda to the power x upon x factorial x from 0 to infinity. So e to the power minus lambda will be outside, and this will be 1 plus lambda to the power 1 by 1 factorial plus lambda square by 2 factorial and so on. So if you remember in M1 Maclaurin's theorem, so this is nothing but e to the power lambda, and that is equal to 1. It is really interesting that though it is taking infinite number of values, for every value there is some probability, and addition of all these properties is exactly equal to 1. Then we can find mean also. Mean, the formula is summation x into corresponding probabilities for all possible values of x, and it will be lambda. After finding, it will be lambda. You can find variance of x also. Again, I have given the formula. Expected value of square bracket x minus expected value whole square, and that is expected value of x square minus square of the expected value, and that will be lambda again. So for Poisson distribution, mean and variance both are exactly the same and exactly equal to the parameter lambda. Lambda is the only parameter in case of Poisson, and that is also mean. Now here I'm going to show this and can solve this problem as here. If I define x as number of penalties on traffic violators. So number of penalties, I will be defining x as number of penalties a particular day. So x follows Poisson distribution with parameter lambda. But what is lambda? We know that if x follows Poisson distribution with parameter lambda, then mean of x is nothing but lambda. So 5 is the mean. So that's, and therefore property that the random variable x takes particular value small x is equal to e to the power minus 5, 5 to the power x upon x factorial, and here x from 0, 1, 2 until infinity. And what is our property that there will be less than 4 penalties on a day. So at least 4 means x less than equal to, so at the most 4 means x less than equal to 4. And here less than 4 means strictly, it really matters a lot. Less than equal to, because here x is a discrete type of random variable. So this is property that x equal to 0 plus property that x is equal to 1 plus property that x is equal to 2 plus property that x equal to 3. We have to find these 4 properties and we have to add together. Every property is to be found by making use of this formula, and e to the power minus 5 will be common, 5 to the power 0 by 0 factorial plus 5 to the power 1 by 1 factorial plus 5 to the power 2 by 2 factorial plus 5 to the power 3 by 3 factorial as such, and we will be getting the answer. I'm not interested in that, so that can be done. Then continuous probability distributions. Yes. So in this also, that is another very interesting part. I have already told that if a random variable is taking uncountable number of values, then that is going to be a continuous type of random variable. Now, suppose x is a random variable which follows some continuous type of probability distribution, then yes, it may have some number of parameters. In case of binomial, we have seen there are two parameters n and p. In case of Poisson, there is only one parameter lambda. Now, here also there may be one, two, or more parameters possible. And the probability formula is small f of x. This is probability density function. Density function. It satisfies two properties. Small f of x is going to be greater than or equal to 0 for any real value of x. And the second is integration of f of x dx for all, or you can say integration minus infinity to plus infinity f of x into dx. This is exactly equal to 1. So if these two properties are satisfied by some f of x, then we can treat that it is a probability density function. That is a formula for a continuous type of random variable. And again, if you want to find what is the mean will be integration again over r or minus infinity plus infinity x into f of x into dx. Again, you can find expected value of x square by that formula, integration minus infinity plus infinity x square into f of x into dx. And after that, variance of x, variance of that distribution is the simplified form is expected value of x square minus square of the expected value. Okay. So as such, find the value of a such that this will be a following proper probability density function. So this is, so we must have integration f of x dx must be equal to 1 from minus infinity to plus infinity. Therefore, there's minus infinity to 1, 0 into dx plus integration 1 to 2 a into x minus 1 into 2 minus x into dx plus integration 2 to infinity 0 into dx, and that is equal to 1. Therefore 0 plus a is outside, then integration 1 to 2, then minus x square is there, then 2x plus 1x 3x, and the constant term is 2 dx plus 0 is equal to 1, and therefore a, then minus x cubed by 3 plus 3x square by 2 minus 2 into x from 1 to 2, and that is equal to 1. Just for to simplify this here, and that can be done. Minus 8 by 3 plus 2 will be 6 and minus 4 minus 1 by 3 plus 3 by 2 minus 2. This is equal to 1. Just go on simplifying. So it will be plus 2 and minus, it will be minus 2 by 3 minus, and again 6 minus 2 plus 9 minus 12. If I'm correct, and this is equal to 1, therefore a into This is minus 4 by 6 minus minus 3 minus 5 plus 5. It's equal to 1, and therefore A is equal to 6. A is equal to 6 is the answer. So this can be done. When we put A equal to 6, then only it will be a property density function. Then the probability density function E. This is, again, let me write. F of x is equal to 1 upon 5 for 0 less than x less than 5. So actually this is uniform distribution in case of discrete. X equal to 0, this is x equal to 5, and this is 1 upon 5. So this total area must be equal to 1. If we integrate, integration f of x from 0 to 5, that will be 1. So this is, and quickly, what is property that E lies between, actually it is x lies between 2 to 4, 2 less than equal to x less than equal to 4. You can say less than equal to, it really doesn't matter because here x is a continuous type of random variable. So here integration 2 to 4 f of x dx 1 by 5 into dx. So this is equal to 1 by 5 into x from 2 to 4, and that is equal to 2 by 5 or 0.4. This is the answer. Let us move. I do not know how many problems are there. Okay. For the function fx is equal to a plus bx, x from lies between 0 to 1, to be a valued PDF, which of the following is correct? So again, the definition, if it has to be a valued probability density function, the first condition is f of x must be greater than equal to 0 for any real value of x. Okay, we are not going to get something fruitful from condition 1, so let us try to use condition 2. Integration minus infinity to plus infinity f of x into dx is equal to 1. And therefore, here integration minus infinity to 0, 0 into dx plus integration 0 to 1, a plus b into ax into dx plus integration 1 to infinity 0 into dx, and this is equal to 1. Therefore 0 plus ax plus b into x square by 2 from 0 to 1 plus 0 is equal to 1. Therefore put x equal to 1. So a plus b by 2 is equal to 1. So actually we are getting only one equation and there are two unknowns. There are infinite number of solutions. But fortunately in such type of problems, we must have the options. So let us see the options one after the another. So A is equal to option A is equal to 1, B equal to 4. So 1 plus 2, 3. So A cannot be the answer. Option B, A equal to 0.5, B equal to 1. So A is equal to 0.5 and B by 2 will be 0.5, that is equal to. So B is the correct answer. The probability density function of a random variable x is given by this, the mean. So yes, so actually you can verify, but not necessary that once it is said that it is a probability density function, then the integration of f of x from 0 to 2 must be equal to 1. And the next problem is asked is expected value of x. And the formula is integration minus infinity x into f of x into dx. So this is equal to integration Again, I'm not going to write the things from minus infinity to 0. That first term is 0, but after that 0 to 2. X into f of x is x into 4 minus x square upon 4 into dx. And one more term is integration 2 to infinity x into 0 into dx. So I will not write that. This is 1 by 4. Then integration 0 to 2. So first term is 4 into x square minus x to the power 4 into dx. So this is equal to 1 by 4. 4 into x to the power 3 by 3 minus x to the power 5 by 5 from 0 to 2. So this is equal to 1 by 4. You have to solve this and you will be getting that answer. So I'm not interested to evaluate this, so you can do it. 2 to the power 5 will be 32 by 3 minus 2. Again, it will be 32 by 5. So this is equal to 32 by 4. 1 by 3 minus 1 by 5. So this is equal to 32 by 4. So 15, 5 minus 3. So it is 16 by. Okay. So if I am correct, it will be the answer. So as such, many more things are there. But whatever the things, I would like to share. So this there is normal distribution also. I will give some glimpses about normal distribution because that is the most useful. The king of all the probability distributions is the normal distribution or Gaussian distribution. So I have not prepared some PPTs, but it is in the form of word. Let us try to understand. A continuous random variable x is said to follow a normal or Gaussian distribution if its probability density function is 1 upon root 2 pi into sigma e to the power minus 1 by 2 into x minus mu upon sigma whole square. Here x can be any real number and mu is the first parameter, sigma is the second parameter. Also the range of mu is from minus infinity to plus infinity and sigma any positive real number. Notation x follows normal distribution with parameters mu and sigma square. So as it is a probability density function, f of x is greater than or equal to 0 for every real value of x, and integration minus infinity to plus infinity f of x dx will be equal to 1. We can prove this. If x follows normal with mu and sigma square, mean is mu, first parameter is mu, and second parameter is variance, then it is the distribution is perfectly symmetric, bell shape. Being symmetric, mean, median, mode, all will be equal and to mu. And this is the very important property. If x follows normal with mu and sigma square, then z equal to x minus mu upon sigma follows normal distribution with mean 0 and variance 1. So normal 0, 1 is called as standard normal distribution, and the z variable is called as standard normal variable. So this is the graph. Actually, x-axis is asymptote, means now it is not touching. The curve is going to touch x-axis on both the sides at infinity. It is perfectly symmetric about x equal to mu. So these are the properties. And yes, if we integrate, integration minus infinity to plus infinity 1 upon root 2 pi sigma e raised to minus 1 upon 2 x minus mu upon sigma whole square dx, you will find that is exactly equal to 1. And these are the three different normal distributions. All these three have the same mean 100, but the variances 25, 100 and 400 are there. So you can understand that the tallest one has the least dispersion or variation. So sigma v is going to be the least, like that. So flat will be having maximum variation as such. So symmetry, 50% at left side, 50% data at right hand side. So it is symmetric about mu. And this is very important. Sigma limits. And what are the three sigma limits? Actually, 99.73% of the total observations lie within three sigma limits. Means mu minus, the values lying between mu minus 3 sigma to mu plus 3 sigma are 99.73%. 95.45% of the observations lie within 2 sigma limits, and 68.27% of observations lie within the sigma limit. Okay. Now, when we are asked to find the probability in case of normal distribution, then again, yes, if you are asked what is the probability that the random variable takes value from minus 15 to plus 50. So integration minus 15 to plus 50, then so much complicated a probability density function with numeric values of mu and sigma square is absolutely impossible to evaluate with. And for that, we are making use of the most important property of normal distribution, means x is converted into z, and these are the different probabilities which have been tabulated. We have to take help of this, otherwise we cannot find the probabilities relating to normal distributions. So these are different problems. Now I am going to discuss some of the problems here. 2,000 students appeared for an exam. Average marks were 50% with standard deviation 5%. How many students are expected to score at least 60% marks, assuming that marks are normally distributed? So way to properly define first, x is the percentage of mass scored by a student. So by a student. So for every student, there is some value of x. As student changes, value of x also changes. Here x follows normal distribution with mean mu equal to 50 and variance is equal to 5 square. We have to be square very much careful. If standard deviation is given, then the second parameter is to be square of that. If variance is given, then the second parameter will be itself. In this standard deviation 5 is given, so second parameter is 5 to the power 2. Immediately z equal to x minus 50 upon 5 follows standard and normal distribution. And what is this? How many students are expected to score? How many students out of 2,000 are expected to score? Let us forget about number of students. Let us talk about the probability that a randomly selected student among these 2,000 is going to score at least 60% marks. So the probability that a student scores at least 60 is probability that a greater than equal to 60. So we have to convert it in terms of z. Probability that x minus 50 upon 5 has to be greater than or equal to 60 minus 50 upon 5. That is probability of z greater than equal to 2. Now the interesting thing is that for z is equal to 2, this much area. So that area is nothing but between the lines z is equal to 0 and z is equal to 2. So between z equal to 0 and z equal to 2, 0.4772 is the area. Then what we want probability of z greater than equal to 2. So probability of z greater than equal to 2. So we want to know the area of this shaded region. And that's why we know that it is symmetric. Now this is Z, this is not X, and Z has means 0, so it is symmetric about Z is equal to 0. To the left of Z equal to 0, 0.5 area, and to the right 0.5 area. And we know between Z equal to 0 and Z equal to 2, the area is 0.4772. So the remaining has to be 0.5 minus 0.4772, and that is 0.0228. So expected number of students among 2000 will be scoring at least 60% is equal to 2000 into the probability that a student scores at least 60%. That is 45.6 and rounded up to 46 like this. So as such, we'll be discussing some problems on normal distribution, and then we'll be having a pause. The height of students in a class follows normal distribution with mean 190 centimeter and variance 80 centimeter square. Among 1000 students from the school, how many are expected to have a height above 200 centimeter? Again, the area is also given. So here X is the height of student in the class in centimeter. X follows normal with mean 190 centimeter. In this problem, variance is given. So second parameter is that's it itself. So Z equal to X minus 190 upon square root of 80 follows standard normal. Now we'll be finding the probability that a student has height about 200 centimeter, probability that X greater than 200. So this is probability that X minus 190 upon square root of 80 greater than 200 minus 190 upon root 80. That is probability of Z greater than 1.118. And again, the same type of problem here. The area was given as 0.3686. So above that, 0.5 minus that. And then we have to multiply by 8 by 1000. Okay. Then the lifetime of an article has a normal distribution with mean 400 hours and standard deviation 50 hours. Assuming normal distribution, find expected number of articles out of 2000 whose lifetime lies between 335 hours to 465 hours. Again, it is given. So X is the lifetime of an article in hours. X follows normal with 400 and 50 square. So Z equal to X minus 400 upon 50 follows standard number. Now probability 335 to 465. So probability that 335 less than equal to X less than equal to 465. So this is probability that 335 minus 400 upon 50 less than equal to X minus 400 upon 50 less than equal to. So we have to do the same operation, that is probability of minus 1.3 less than equal to Z and Z less than equal to 1.5, and this is the shaded region. From the problem itself, the area between Z equal to 0 and Z equal to 1.3 is 0.4032. And required probability is nothing but the area of the shaded region. It must be 2 times because it is perfectly symmetric at Z equal to 0. This is another variety. 2 times the area between Z equal to 0 and Z equal to 1.3, and that is equal to 0.8064. Then for finding expected number, we have to multiply by total like that. Then the lifetime of certain component has a normal distribution with mean 400 and standard deviation 50. Assuming normal, find expected number of components in a sample of 1000 components whose lifetime lies between 340 hours and 465 hours. So many things are given. X will be lifetime of an article in hours. X follows normal with 450 square. So Z is equal to X minus 400 upon 50. That follows standard normal distribution. The probability that, so when I was speaking probability, then that is related to only one entity. that the lifetime of an article lies between 340 to 465 hours. So probability that 340 less than equal to x less than equal to 465. Then perform the same operations so that it can be converted into standard normal. And this minus probability that minus 1.2 less than equal to z and less than equal to 1.3. So the shaded area. The next thing is that when we are given area between z equal to 0 and z equal to 1.3, that is 0.4032. That is obvious. One more thing, we have been given area between z equal to 0 and z is equal to plus 1.2, and that is 0.3849. Again, using symmetry, whatever the area between z equal to 0 and z equal to plus 1.2 is exactly same as the area between z equal to minus 1.2 and z is equal to 0. So using symmetry, we have to add this. So this was another variety. And then we have to multiply by so much number. Like this. Now, here, in a sample of 1000 cases, the mean of a certain examination is 14 and standard deviation 2.5. Assuming the distribution to be normal, find the number of students scoring between 12 and 15. Again, here x score of a student, x follows normal with mean 14 and variance 2.5 whole square. So z equal to x minus 14 upon 2.5 follows normal 0. Now, the probability that a student scores marks between 12 and 15. So this is probability that x lies between 10 and 15. You can say less than or less than equal to, it really doesn't matter, as here x is a continuous type of random variable. So here that is equal to probability that 12 minus 14 upon 2.5 less than equal to x minus 14 upon 2.5 less than equal to 15 minus 14 upon 2.5. So this is probability that minus 0.8 less than equal to z and z less than equal to plus 0.4. Again, see the area between z equal to 0 and z is equal to 0.8 is given. So that must be the area between z is equal to minus 0.8 and z equal to 0. Similarly, state away area between z equal to 0 and z equal to 0.4, that is 0.155. So these are to be added together like that. And so expected number of students out of 1000 scoring marks between 10 and 15. So the probability is to be multiplied with 1000. And that is equal to 444. Or to round up. This is a little problem. The shape of a cumulative distribution function. So actually, cumulative distribution function, this is S-shape. S-shape is the answer. So cumulative distribution function, this is another concept in regard to continuous coordinate distributions. Now, x1, x2 be two independent normal random variables with means mu1, mu2 and standard deviation sigma 1, sigma 2 respectively. Consider y equal to x1 minus x2. mu1, mu2 are given, then y is normally distributed. Now I try to explain it in the best possible way. X1 minus x2. X1 is normal with mean 1 and variance 1 square. X2 is normal non-random variable with mean 1 and variance 4. And independent. So x1 minus x2 again follows normal distribution, no doubt about that. And what will be the mean of y? Mean of y will be equal to mean of x1 minus mean of x2. Means 1 minus 1, 0. Mean is 0. Y has mean 0. It is normal distribution. So C and D cannot be the answers. A or B. It is normal with mean 1. And remember that what will be the variance of y? Again, yes, I can prove very simple thing. Statistics is a very beautiful subject. So many things theoretically are possible. Variance of y will be equal to variance of x1 plus variance of x2. And hence, variance of x1 is 1, variance of x2 is 4, 1 plus 4 is 5. So B is the correct answer. Like this. Yes, it is explained here itself. Okay. The sum of two normally distributed random variables x and y is also normally distributed. Then there are some other problems in relation to this. So I will go back to here and I'll be sharing. I can discuss some part of normal distribution, but I think that we'll stop now. I think that the link was shared. You must have given the attendance there itself. So I will like to stop. I will come with some videos topic wise of different types, not only in statistics and probability, but for other subjects also, other topics. So for today, let us have a goodbye. Let us stop. Have a good day ahead.